Hi everyone. Today we're going to learn about alcohols, and this will be lesson 5.5. Okay, so alcohols. So we're used to thinking, when we say the word alcohol, obviously that means something to us. Alcohol is something we drink, but then we also have things like rubbing alcohol, which people use to sterilize things, right? Now, in terms of organic chemistry, the definition of alcohols are compounds that have a hydroxyl group. So they have a hydroxyl group as a radical that's attached to the hydrocarbon chain. And so the general formula is going to be R-OH. So R is the hydrocarbon, so whatever, right? So let's say CH3, CH2, OH. That's how you would see it written as an example. So that would be your R, and then the hydroxyl group is the radical there. Okay, so when we're naming these, most of the other rules of naming are still going to apply here. You're going to name the longest hydrocarbon chain, so look for that parent chain. The longest one is the parent. Now you're going to, name it normally. So let's just work through it here. So if we look at this example here, so if I look through 1, 2, 3, 4, so I've got 4 carbons. So the prefix for 4 is but, right? So that's butane. And then it says drop the E and add OL. So I'm going to drop, I actually have an eraser on here. Drop the E, add OL, so that butane now becomes butanol. And that's it, that's butanol. That was actually much easier. Now you have to indicate where it is. So we're going to start numbering from the hydroxyl, okay? So the end that's closest to the hydroxyl group. So instead of numbering here, I would start numbering on the right-hand side. So 1, 2, 3, 4. So this would be called 1-butanol here. Now, we can have more than one hydroxyl group substituted on a carbon. So for example, on a hydrocarbon chain. So for example, here we've got, oops, I meant to do the whole thing. We've got 2 hydroxyl groups on that. So when that happens, so if 2 hydroxyl groups are substituted, it's called a diol. So you're going to retain the E when you do this. So this one, you're going to call this, so this is going to, you know what, we'll talk more about that. I have an example for this on an upcoming slide, so we'll deal with that there. So we've got a diol or a triol here, so we can have 3 that are substituted as well. So again, the OH, the functional group, is given preference and must have lowest numbering. Okay. So we'll work through some examples here. These, of course, you all have in your notes here. So the first one, we've just got 1 carbon. So instead of methane, right, that would have been methane, we drop the E and add the OL, so methanol. This is also, sometimes you'll hear it referred to as methyl alcohol. Okay, so that's wood alcohol, and you don't want to drink that. That would be very, very bad. You'd die. It'd be poisonous to you. Now, the next one is ethanol. So grain alcohol, that's the one that people drink, which is also poisonous, right? Depending on the dosage. If you drink too much of it, you'll get alcohol poisoning. So if we look here, though, again, it's on the N carbon, so it's going to be on the first one. So that's 1 ethanol. And again, we refer to that sometimes as ethyl alcohol. The next one, propanol, so now I've just got 3. This one now, the alcohol, the hydroxyl group is not oh, that got messed up, is not on the end carbon, it's on the middle one. So here, we're going to call that 2-propanol. So again, 3 carbons in a row, and it's on the second carbon. So that number is going to tell you where that hydroxyl group is located. And 2-propanol, commonly known as rubbing alcohol. The next one here, this one, we've got a radical, a methyl group, as well as our alcohol here. So we're going to go 1, 2, 3. So the name of this one is going to be 2-methyl-1-propanol. That's the name of that one. Now, these next 2 examples, and again, you already have these in your notes here. These are our diols and our trials. So we've got a diol here because we've got 2 hydroxyl groups here. So the name of this, then, we have to indicate where those are. It doesn't matter which way you start numbering from because they're the same. But this one's going to be 1 comma 2 dash. And now we look in the parent chain, we've got 2 carbons, right? So this is going to be so now we keep the E, so ethane diol is the name of that. And this is actually antifreeze, the formula for antifreeze. So 1,2-ethane diol. So we keep that E there. So don't forget that E. You'll lose half a mark if you forgot that. The next one is a trial. So we've got our three of them, 3 hydroxyl groups there. So this is going to be 1, 2, 3 propane trial. And again, don't forget that E there. Okay, so propane and that's an O. Trial. Okay. So these are, like, it's pretty straightforward. It's just kind of more of the same. I hope you guys are enjoying this unit. Some of you I know probably like drawing them. I actually really like drawing them. I find it oddly satisfying to draw them. Anyways, okay, primary alcohol. So we've got different types of alcohol. We've got primary, secondary, and tertiary. So primary, this is when the hydroxyl group is attached to an end carbon. So this is our hydroxyl group. So what you're going to do, you're going to look at the carbon that it is attached to. So the hydroxyl group is attached to this carbon, this first carbon in the 1 position here. And now we note that this carbon is only bonded to one other carbon. Let me do that in green. So it's only bonded to one other carbon. So that means that this is a primary alcohol. Now, a secondary alcohol, again, we've got our hydroxyl group here. So I look at the carbon atom that the hydroxyl group is attached to, and then I look, well, how many carbons is that one attached to? And it's attached to 2 other carbons, and that's where we get the secondary from. So we have a secondary alcohol here, and then we look at a tertiary, and then we look at that hydroxyl group is attached to this carbon. Yes, I know you're not backed up. And this carbon, oh my God, this carbon is attached to, okay, I'm gonna leave that, 1, 2, 3 other carbons, and this is where we get our tertiary alcohol here. Okay, so it's attached to 3 other carbons. Now, the reason why that is important, and for you to be able to identify that, is because it causes differences in chemical behavior. Now, we're not going to talk about those differences, but if you end up taking organic chemistry in college or university, that's when you would learn more about that. Okay, so that's it for this lesson. You're going to go through the assignment is worksheet 4, part 1, and I will post the answer key up for that so you have it. Okay, thanks everyone.